So thank you guys for having me. And you're right, this is actually my second time. The first time was a long time ago, but I'll tell you a little bit about that, just a little bit about me. My first company was called Hadapt. If you haven't heard of Hadapt, that's okay. Hadapt was actually one of the first SQL engines for Hadoop. It was actually based on a project in the Yale Computer Science Department. And the idea was to think about Hadoop as a real data warehouse or analytics platform. And I think we were pretty early to think about SQL on Hadoop in that way, really before people were calling it SQL on Hadoop. That was back in 2010. We raised venture capital, built that business over 4 years, and then ultimately sold that to Teradata, which I assume most of you have heard of Teradata. Teradata, of course, is a very large data warehousing analytics platform. If you work for a large bank or a large retailer or a large media company, you probably have Teradata. I spent 3 years there as a vice president and general manager of a business unit focused exclusively on open source software. So a little bit different from Teradata's core focus, but looking at different things. And one of those things was an open source project called Presto. How many of you guys have heard of Presto? Good, Matt has, that's good. All right, a few of you, that's okay. You'll hear about it a little bit in this talk. And so we founded Starburst actually about 1.5 years ago. It was the same team, much of it was the same team from Hadapt, who then went to Teradata and then started this company. So we've been doing SQL on fill in the blank for quite a while. And really excited to build this business. So we are the Presto company. What is Presto? Presto is an open source project. It was first created at Facebook. And it was created really as their next generation data warehousing, data analytics infrastructure. So I'm sure most of you have heard of Hive. Hive is a SQL offering on top of Hadoop. Facebook also created Hive, but they needed something faster. They needed something more interactive that could deliver better performance. And secondarily, they needed something that would allow them to query multiple data sources. So whereas Hive was exclusively focused on Hadoop, they needed something that could query data in Hadoop as well as MySQL. Facebook happens to run the largest MySQL deployment as well. And so thus was born Presto. And this is about 2013, 2014 timeframe. We got very involved when we were at Teradata, like I mentioned, and our team actually became some of the leading committers to this project. In fact, we're about the largest, we are the largest group of committers outside of Facebook, almost splitting it 50-50 between Facebook and our team. In a nutshell, we like to say that Presto is SQL on anything, and that's really what makes it unique, is the ability to query data anywhere. This is maybe a little hard for some of you guys to see, but it shows at the top a variety of popular BI tools that you can connect to using ODBC or JDBC drivers, and on the bottom a variety of data sources. And you'll see Hadoop, traditional databases like Teradata, Oracle, MySQL, as well as NoSQL databases like Mongo, Cassandra, Kafka. Even S3 compatible object stores that you may be familiar with, and of course S3 itself. If you're an AWS user, you might have heard of something called Athena. Athena actually runs on Presto under the covers. So that is the technology behind Athena. But believe it or not, my talk is not about Presto specifically. We can take questions about that if you guys have them in the Q&A. But instead, to give a little bit more of a higher level talk about what I think to be one of the most important considerations for any enterprise data architect today thinking about their next generation architecture, and that is this idea of optionality. A well-known data architect, I don't know if you've heard of this guy, born in Brooklyn, I think. I don't know what they want from me. It's like the more data we come across, the more problems we see. And I think that's a problem that many data architects can relate to. This should be very familiar to Matt, because back in 2012, I don't know, was this the first one? What year was the first one? Probably around here, right? They did an incredible landscape of all of the big data companies. And you can see just how much stuff is going on there. Now look at 2018. It's insane, right? And more than likely, you have more than a few of the things on this chart. And if you're a big company, you might have like most of the things on this chart. And that creates some interesting problems for you. First of all, a lot of this is being driven by more and more data volumes, data velocity, data variety. And as a result, you're trying to find the right tool for the right job. But the problem with that is over time, that creates a lot of data silos. And in particular, as you create these data silos, you're confronted with vendor lock-in, particularly if you're using proprietary databases or storage as your underlying infrastructure for these different use cases. I'll give you a very personal example of vendor lock-in. About a year ago, I was moving into a new home in Boston, which is where I live and where we're based. I had done all the right things. I called the gas company ahead of time before moving in, and I said, moving in, start my clock on this day. Had everything paid for, everything was good. But about 3 days after we moved in, the heat was turned off, the gas was turned off, and it was actually freezing cold. And we couldn't shower, we couldn't cook, we couldn't stay warm. My wife was all mad at me. She assumed that I just forgot to do all of this. I called, and I was obviously very upset, and they shared with me that the prior tenant, the prior person who'd lived there, wasn't paying their bills. And so even though they had the order to start for me, the order to stop had preceded the order to start. And so as a result, the order to shut off our power, our gas, took place before, somebody got the word that they should, switch it to my billing. The point of this story is there was literally nothing I could do, right? It's a gas utility. There's only one. It's a monopoly, right? So that is the epitome of vendor lock-in. There's literally no option. I have to deal with this terrible service, the fact that, I'm freezing cold and my wife is all upset. So the key thing in all of this is if you're just, remember one thing from this entire talk, it's optionality. Some of you guys are laughing. This is from The Graduate. Wonderful movie if you haven't seen it. In that film, they talk about plastics. He says, I have one word for you, plastics. That's the future, right? And I believe very strongly that as far as IT architectures are concerned, that word is optionality. So what does optionality mean? The formal definition is the quality of being available to be chosen, but not obligatory. And that is key. It is an option, not an obligation. In financial terms, this comes from Nassim Taleb's book. You might define it as the property of asymmetric upside, preferably unlimited, with correspondingly limited downside, preferably tiny. So for those of you who work in finance, you probably understand the power of optionality. So let's talk about it in the context of architecture. The three keys, in my view, to a data architecture that can stand the test of time are first and foremost, embrace this new frontier of storage compute separation. I'll talk about that in a moment. Use open data formats wherever possible. That is really, really key in my opinion. And ultimately, future-proof your architecture with abstraction wherever that makes sense. We'll talk about that. All right, so first and foremost, storage compute separation. So hopefully many of you already know what this means, but with the emergence of the cloud, one of the things that changed is that compute and storage are now separate, right? So we'll just use AWS as an example here. You have EC2, which is your compute, and you have S3, which is your storage. So in the past, your hard drives and your processors were all in one monolithic, hardware machine. You now have these things separated. And what that allows you to do is scale these up and down independent of one another, which is really key because now you can leave all of your data in S3, which is essentially your lowest cost option, right, in the cloud, and you can spin up these EC2 nodes as needed. As demand increases for whatever workload you're doing, and as a result, you have all this cost flexibility because you're only paying for what you use. You can scale up and scale down. Whoops, I'm moving on here. Hold on. There we go. The second point is use open data formats. So one of the great things that the Hadoop era brought to us, with all the billions of dollars of venture capital poured into Hadoop companies, is some great open file formats. ORC file is one of the most popular. Essentially, Facebook runs all of their infrastructure using ORC file. Parquet, Netflix uses that for all of their infrastructure, essentially. Avro, sequence file, and CSV. But I would say ORC and Parquet are the two most popular for doing analytics in particular. And the reason is that data is stored in a columnar format. So you're essentially getting columnar database-like performance out of this file format that is open source. So there's no vendor lock-in. That means, Hadoop's various projects can read this data, Spark can read this data, and of course Presto can read this data as well. But because it's an open file format, you're going to continue to have more and more options that can access data in this format. And by doing that, again, no vendor lock-in. You don't have the issue of, now I need a major migration project to get out of proprietary database X into proprietary database Y. And I think that's a mistake that a lot of people are making today is, There's a very popular database company right now that I won't mention that is very, very popular, has raised a lot of money. And once again, it is that story of vendor lock-in all over again because it's proprietary storage. So even though that data lives in S3, it's proprietary storage. And I think that's a key point to think of. The last point is future-proof your architecture. And what I mean by that is we talked about how compute can scale up and scale down. But what about if the data source underneath eventually changes, right? So, a few years ago, a lot of people were moving data from, let's say, a large database or data warehousing appliance into HDFS, the Hadoop file system. But now, many people are moving that into S3, and therefore their entire architectures are changing. You might have had Cloudera or Hortonworks on-prem, and now you're thinking about, how that's going to look in AWS. You might still have a Teradata system that you bought and has a lot of really critical, customer data in it. You might be looking at, a whole host of other data sources like Kafka or MongoDB or some new technology X. And I think the point is, throughout history, these technologies are going to continue to change. And so how can you prepare yourself for those inevitable changes? And my view is creating a SQL abstraction layer, at least in the context of SQL analytics, is a big part of the answer. And by doing that, if you use something that allows you to separate storage from compute and allows you to query any data source, you can now insulate your users from the underlying data itself. So they don't have to know, is it in this data source or that data source or that data source. You can make those migration decisions completely independent of the user experience, the analyst experience, if you will. So just to recap, again, embracing storage compute separation, using open data formats, and future-proofing your architecture with abstraction. To me, these are the three keys to ultimately achieving what I think anybody in the enterprise wants, which is freedom. The freedom to do new things, the freedom to manage costs, the freedom to define and create one's own future. So with that, I will move to questions.
Thank you very much. So you started talking a little bit about the company. Do you want to
Sure.
finish that part? I guess, where are you as a company in terms of development? How many people? How long have you been around?
Yeah, sure. So we've been around about 18 months. What's different about this one, well, actually a lot of things. It's funny, this company is both the same and very different at the same time compared to Hadapt. So Hadapt was a SQL engine. This is, again, a SQL engine. They're very similar from a technical perspective, but fundamentally the businesses are so different. This is obviously an open source project. We have very wide adoption. You saw some of the logos of some of the public users. It's a very global business. The other thing that's very unusual about this one is we haven't raised any venture capital thus far. And in fact, we're actually profitable, and we've been running profitably from day one. And I will say we cheated, and I'll explain how we did that. We were working at Teradata, as I mentioned, and we collectively left Teradata at the same time to start this business. And in doing so, worked out a deal that allowed us to continue to work with the number of customers we were working with around Presto. So we basically started with customers, started with revenue. And in that sense, this has been kind of like starting with a head start, right, with a running start. And so that's been really exciting. We're roughly 25 people today and growing organically thus far. I won't say that we'll rule out raising money ever, but I think being able to control your own destiny thus far has been a wonderful experience.
Very good. No VCs is a wonderful experience.
By the way. So the question's on the storage compute separation. Do you think in regulated industries like healthcare, where it takes a lot to get HIPAA compliance, high trust certification, that paradigm would still hold? Because I can see benefits of working with a vendor that helps compliance both at the storage layer as well as the compute layer.
Mm-hmm. Yeah, great question. So what we've found is that that really what matters, I think, from a HIPAA perspective is the storage piece, really. Like with Presto, since that's my area of greatest expertise, Presto doesn't store any data. It's not a traditional database in that respect. And so, we're basically by definition HIPAA compliant because we're not storing it in any way that could be potentially problematic. We do wire encryption, and we have some built-in security around role-based access control, Kerberos, LDAP, the whole 9 yards. But ultimately, we find that we go through procurement cycles a lot faster because we don't have to clear those security hurdles that I think you're mentioning. So I think that's really a burden on the storage side, and I think you can treat these independently. But great question. Is that my chair?
Thanks for attending this. Could you speak around business models for open source companies? How you doing it? You've got a big other company contributing to your source.
Yep. Yeah, so obviously in our case, the big other company is Facebook. And fortunately, they're not in the business of monetizing that or competing with us in any way. So it's very much a collaboration. And I think we have kind of the best of all worlds in that respect, in that we work very closely with them. We have very complementary roadmaps in the sense that Facebook really cares about what Facebook needs, which is often around performance and scalability. And I think those are also benefits in that the project has been proven at extreme petabyte scale. By contrast, we're focused on also performance, but things like security and role-based access control was something we added last year, for example, or connectors to various data sources, connectors to Teradata, connectors to Oracle. And so we've been very complementary in that respect. It is very much a community-driven project. So Airbnb, Uber, Netflix, they all commit code to the project as well. And I think everyone benefits from that. So Uber contributed a bunch of features around geospatial analytics. They're obviously very interested in geospatial. And what's funny about that is now most of the world's ride-sharing companies around the world actually run Presto for their analytics because of that. So that's Lyft here in the US, that's Grab Taxi in Singapore, that's Ola Cabs in India, that's Careem in the Middle East. I mean, it's been incredible how that's gone. From a business model perspective, our business model is pretty simple. It is what I would call a classic open core model. So the core of Presto is entirely open source. Everything we do from a performance standpoint, we contribute directly back into the open source. Everything we do from a robustness, bug fixes, security patches, that is, all goes back into the open source. And then we have kind of our extra enterprise features, and those are mostly around security and connectors and ease of use. We have a new management tool as well.
I was wondering, given that Spark is also separated compute from storage, how does Starburst stay competitive with companies like Databricks?
Yeah, great question. So we actually think of Databricks as kind of a role model company for us. I think that obviously we play on-prem and in the cloud. Databricks is just in the cloud. But I think what they've done broadly as a business is something that we look up to and aspire to be. From a technical perspective, the way I would answer your question is we actually think Spark is 95% complementary. And what I mean by that is we really think Spark is best for your data scientist who's doing machine learning models, maybe even for ETL workloads, whereas Presto is laser focused on SQL analytics and BI. That's our target market. And yes, there is Spark SQL, which is a sub-project, and that's the 5% overlap. But I think anyone who's trying to do high concurrency will usually realize that Spark is not built for high concurrency. It's a great tool, and I would say most of, if not all of our customers use it also, but again, for different use cases, for machine learning, for the data scientist, for sort of programmatically accessing your data, as opposed to SQL and BI. Good question.
So just as a follow-up to that question, how do you think about the separation of computation and storage when the storage, the data sets get so large, right, that the network latency starts to become a problem? You need to bring the compute to the data rather than the data.
Yeah, I mean, so one of the things that at least Presto does is we try to push down as much as we can to that source system, first of all. So if you're already storing data in, let's say, Oracle or Oracle and Hadoop, and you want to do a join between the two, for example, we would push down as much filtering and predicates to the Oracle system as possible to sort of minimize the data movement over the network. So that's sort of a tactical trick that we do to minimize that. But I would say in general, it's going to depend on your use case to some degree. I mean, at Facebook, they run 1,000-node Presto clusters with petabytes of data and are able to get that done with Presto.
Very nice.
All right.
Really appreciate it. Thank you.
Thank you.